In this video, I would like to introduce a new advanced motion model. Why do we need a new motion model? Because the basic previous one was oversimplified. We couldn't describe using it a circular motion. We couldn't describe a right turn, left turn, or even full circular motion. Circular motion is extremely important when designing self-driving cars. We want our car to be able to shift or turn right, left, or even to make a full circular motion. So, in this video, what are we going to do? First, we will recap the previous naive motion model, and then I would like to introduce the new motion model that enables us to incorporate circular motion within it. If you remember, our previous motion model looks like this. So the state vector has 4 parameters. We have x, y, a velocity v, and an orientation theta. Now theta is constant. Now the transition from the current state to the next state is the following. So v remains the same because this is a constant velocity model. Theta remains the same because our orientation is also constant. And now we have x final and y final. So basically x final equals x initial or x0 plus this part over here. And y final equals y0 plus this part over here. So again, we have x final equals x0 plus v times delta t times cosine of theta. Now, it is very important to bear in mind that these very simple equations cannot be described using the original Kalman filter. Why? Because both the sine and the cosine functions are nonlinear. If I want to improve my algorithm, I need to allow a changing theta, a changing orientation. So the initial theta will be different from the final theta. And here comes into play our new model CTRV, which stands for constant turn rate and velocity magnitude. What does it mean? It means that the orientation is not constant, but its derivative is. In other words, we can write the orientation as function of t like so. Theta of t, or theta final, equals theta 0 plus omega, the angular velocity, the turn rate, times delta t. And omega can be expressed in radians per second. So our state vector becomes a little bit more sophisticated. We have x, y, theta, v, exactly like before, but now we add the omega, the turn rate. And again, the CTRV model means constant turn rate. Omega is constant. Now, the transition between the current state and the next state can be described using these equations. Again, v is constant, omega is constant, and theta final equals theta initial or theta 0 plus omega delta t. And those are the x final and y final equations. Now, if you want to know how I derived those equations, you can check the link in the description below. So basically, this is what we have. We have a very basic motion model, but advanced enough to enable us to incorporate circular motion, right turn and left turns. And those right and left turns are extremely important when we are programming and designing self-driving cars.